So the first row operation I'm going to be doing on my calculator is this one. All right, so first thing is second matrix. To go to your matrix menu, math, excuse me, times row plus. And so in this case, our multiplier is negative 1/2. The matrix we're working on is A. We're multiplying this negative 1/2 through row 2, because row 2 now contains our new leading 1 right here. And then the row that's changing, when we put this information into our calculator, the row that's changing always goes last, which in this case is row 1. Hit enter, then make sure you always lock that in by hitting store, and then store it as a new matrix A. So we're good. We have a 0 right here above our 1. Let's go ahead and make this 5/2 a 0 as well. So remember that row operation? It was R3 minus 5/2 R2. Okay, so let's go ahead and perform that. Go to your matrix menu, math, times row plus. Put in the multiplier. In this case, it's negative 5/2. The matrix we're working on is A. We're multiplying negative 5/2 through what row? What row? 2, because 2 contains your 1 right there. And the row that's changing is row 3. Lock that in. And you now have completed the second column, all right? You've zeroed this out, perfect. So we always do what? Store matrix A. I know I sound like a broken record, but that's really the point. This is just a very repetitive process. Okay, so we're almost finished. We have one more cycle here of this algorithm to get through this problem. I'm gonna go ahead and write this on my paper now. Let's finish this thing. First 2 columns are set. We now just need to change a third column and we'll have our solution. So what are we trying to do here again? We're trying to create a diagonal of 1s from the upper left-hand corner to the lower right-hand corner, and then 0s everywhere else. Okay, so to do that, we're going to again repeat the process. We're going to do the same thing over and over again until we've created that diagonal of 1s and 0s everywhere else. That's Gauss-Jordan elimination method. All right, so we want this 2 to become a 1. All you have to do to make this 2 become a 1 is multiply it by the reciprocal. So 1/2 is the reciprocal of 2. So you put a 1/2 times the row in which this is located, which is row 3. I'll now use my calculator to perform this row operation. All right, so let's go ahead and do 1/2 times R3. With that being said, understand you could do that in your head. I mean, you get 0, 0, 1, and then 3. But if we're going to use our calculator, we got to be consistent in using our calculator. So don't skip any row operations. That'll mess everything up. All right, so we're going to do the same thing. Go to math menu, times row, and then do 1/2, comma, matrix A, comma. Now the row is 3. Hit enter, and there it is. Okay, I'm going to go ahead and do what? Store matrix A. And I'm going to write this on my paper. All right, this is the final step. We have our 1 set here in our 3 entry. All we have to do is make sure every entry above it is a 0. This is already a 0, so we're good there. All we have to do is make this negative 1 become a 0. So how are we going to do that? Well, we're going to write down the row that needs to be changing. That's row 1. And then we're going to write down the opposite of this number that needs to become a 0, which is +1. And then we're going to multiply it by the row in which we just created a 1. Right here, row 3. I will now use my calculator to do our final row operation. Let's do it. Second matrix, math, times row plus. The multiplier here is 1. And we're multiplying this 1 through what? What's the row in which we just created a 1? Row 3, yes. And then what row is changing? The row that's changing is always your fourth parameter. That's row number 1. Lock that in. Finished. I'm going to now write this on my paper. Okay, so we've completed the Gauss-Jordan elimination method with respect to a 3x4 size, or a system of 3 equations with 3 unknowns. So what does this mean? This means x equals 6. This means y equals -2. And this means z equals 3. So your solution here is what's called an ordered triple. Finished. Now, with that being said, I want to zoom out here if I can and show you this process in its entirety. So look how I set this up. And again, you're going to be required to scan this in and send it to me when we actually have a test on this information. I need to be able to see your work on this. Okay, so notice for the single row operation, just the times row, I have those all first. And then for the multiple types, where we're doing times row plus, I have those second. So everything's aligned vertically, and you just got to try to keep everything nice and neat. Hope that helps. Have a good day.